Hello everybody and welcome to the last video of this chapter and actually what will most likely be the last video of the year. Today I'm just going to go through some examples of finding the volumes of solids of revolution. So there's no new material here. It's more just to see a few more problems and to really be clear on how we can tell whether we need to use discs or washers. So in other words, telling, is this solid that's going to be formed, is it solid all the way through, or does it have a hole in the middle? So that's what we really want to have nailed down by the end of this video. So let me let this adjust here. So like I said, we're going to go through several problems, probably not every one here, but just give you a variety of different problems. So here we go. So we need to find the volume of the solid that's created by rotating the region bounded by y equals 2x minus 4, y equals 0, and x equals 3 about the x-axis. Okay, it says use the discs or washer. So this is kind of what we have to decide. So let's go ahead and sketch a graph of our region. So I know I've got a linear equation. So the y-intercept is going to be -4. It's going to cross x at 2. So here's my line. And then I know that x equals 3 is also a boundary here. So I've got y equals 2x minus 4. And then here's x equals 3. So if I'm capturing the region bounded by 2x minus 4, y equals 0, which is the x-axis, and x equals 3, I'm taking this region here. Now, I'm going to start doing what we did when we created solids with holes in them. I'm going to underline the axis or line that I'm revolving about. So here it says the x-axis, so I'm going to highlight this x-axis in blue. And what we notice is if we're revolving about the x-axis or my blue line, there's no negative space created here. So that tells me this is just going to be the discs method. I don't have to worry about subtracting the volume of a hole. So if I kind of sketch in what I've got here, reflect that, and draw some circles, you can see what I've got is a cone really on its side. So again, this is going to be discs because there's no hole in the center. So again, we know we're working with circular cross sections, so the area of each circle is going to be pi r squared. In this case, since we're revolving about x, I know I'm doing top minus bottom, which in this case, our top is my 2x minus 4. My bottom is just the x-axis, so it's just minus 0. So my radius is 2x minus 4. So my area in terms of x is pi times my radius, 2x minus 4. I'm going to square that quantity. So now all that's left to do is to find the volume. So to find the volume, I'm going to integrate pi times the integral from, let's see, we're going from 2 to 3 here. And I'm going to do 2x minus 4 quantity squared dx. And then I'm going to go to the calculator. So we'll just use the calculator for all of these. So here we go. I'm going to see, let's see if we can get an exact answer. So math 9, what was I? 2 to 3. And I have 2x minus 4 quantity squared dx. As a fraction, that's going to be 4 over 3, and I'm multiplying by pi, so my answer is 4 pi over 3. Okay, so a basic discs problem. So if I look at number 2, I'm going to, let's see, rotate, actually, the region captured by those same curves, so same functions, but now I'm going to revolve it about the y-axis. So let's see how that changes things. So I'm going to draw in my same graph here. 1, 2, 3, 4. X-intercept is 2. So there's my line. I have x equals 3. Okay, now I'm revolving about the y-axis. So again, same region, but I'm going to draw it this way since I'm going around y. And since I'm revolving about y, I'm going to highlight the y-axis. And hopefully what we notice is there's definitely a large negative space here between my region and the y-axis. So that tells me this is going to be washers. I'm going to have to subtract out that negative space. So this is where we're going to have our big R and our little r. So here's my big R from my furthest right boundary to my axis. And then my little r is going to be kind of that inner boundary here to the axis. So for my big R, I have, well, my right boundary here was 3. And let's make a note here, actually. We have right minus left now. So 3, my left boundary is 0, so my big R is 3. Now, I actually need to do a little bit of work here because I know if I'm revolving about y, I need my function solved for x in terms of y. So if I have y equals 2x minus 4, I know 2x is going to be equal to y plus 4. So then x is y over 2 plus 2. So now my little r, this line now is y over 2 plus 2. I'm subtracting my left boundary, which is 0. So little r is y over 2 plus 2. So now for my volume, I'm going to have pi times the integral. Now my integral, my limits have to be y values. So I know I'm integrating from 0. Now if this is x equals 3 here, if I plug in 3, 2 times 3 is 6, minus 4, my upper bound is going to be 2. And now, remember, our integrand is going to be r squared minus little r squared. So I'm going to have my big R was 3, and I'm squaring that. And then I'm going to subtract my little r squared. So y over 2 plus 2. And again, this is in terms of y, so dy. And we'll use our calculator for that. So let's see, math 9 from 0 to 2. 3 squared, I have 9 minus. I'm going to have x divided by 2 plus 2 quantity squared dx. So that's going to be 16 over 3 times pi, so 16 pi over 3. All right, let's see. Last one here. Actually, it's not the last one. It's another one dealing with this same region. So we're going to get really good at sketching this graph here. All right, same region. So let's do this. 1, 2, 3, 4. This is 1, 2. There's my line. Here's my line x equals 3. Now, I am going to be revolving about the line x equals 4. Okay, so since I have about the line x equals 4, right, since x equals 4 is parallel to the y-axis, this is going to be integrating with respect to y. Now, what I notice is, if I draw in my region, there's no negative space between my region and that line that I'm revolving about. So this is going to be another disks problem. So I know, again, we keep going back to this area of circles, right? Our radius, in this case, since we're integrating with respect to y, I know it's going to be right minus left. So in this case, my right boundary is 3. Oh, I messed this up. I'm sorry, guys. I'm revolving about x equals 4. Okay. I made a mistake. So this is actually not the correct line. So I still have my region, but I have to be a little bit careful. Here's my line. And now I know there is actually some negative space between my region and my line. So this is not discs, this is washers. Sorry about that, guys. Okay, so I'm going to have washers. So again, I need to identify my two radii. So there's my big R. And again, in the negative space, and I know it's small here, is my little r. So for my big R, my right boundary is 4. My left boundary is this function, and we already got that in terms of y. We know that's y over 2 plus 2. Now, for my little r, I have my line here, 4, and my inner boundary is just 3. So that's equal to 1. So now I've got my big R and my little r. And again, we're going to go ahead and integrate. So our volume is pi times the integral. Again, our y limits are from 0 to 2. Now I'm going to have my big R squared. So it's going to be 4 minus y over 2 plus 2, quantity squared. And I'm going to subtract my little r squared. And then we're integrating with respect to y. So let's go ahead, pull up the calculator. Integrating from 0 to 2. Now I have to be careful with my parentheses. So I want 4 minus parentheses x divided by 2 plus 2. I'm going to close that first set, and I'm going to close the second set and square it. And then I'm going to subtract 1. And I've got my dx. So I get 8 over 3. I multiply by pi, and I get 8 pi over 3. So hopefully I didn't confuse you guys too badly. But again, that is a washer's problem because I do have negative space between that region and the line that I'm rotating around. All right, the next one actually is with that same region. I'm going to move on so we can see a couple other different types of problems. So we'll skip 4 for right now, and if we need to go over it in class, we can go ahead and do that. But let's move on to number 5. All right, so number 5 says use the disk or washer method to find the volume of the solid created by rotating the region bounded by the x-axis, the y-axis, and y equals cosine x for 0 or x between 0 and pi over 2, and we're going about the x-axis. So again, always get our graph first. So cosine x, well cosine of 0 I know is 1, and then we're only going to pi over 2. Cosine of pi over 2 is just 0, so really we just have something like this. And we're going about the x-axis. So there's my x-axis. And so here, now for real, we do have disks, right? No negative space between that region and the axis. So we only have to worry about one radius. So in this case, our radius is going to be top minus bottom. So our radius is just cosine of x. That means the area of my circle is just pi times cosine of x squared. And now we can find our volume. Pi times the integral from 0 to pi over 2 of cosine of x squared dx. So back to our calculator. This is a nice quick one. So let's see, math 9 from 0 to pi over 2 of cosine of x, quantity squared. Oh, what did I do? I cleared that out somehow. Cosine of x squared dx, 0.785. I don't think we'll be able to turn that. So it's 0.785 pi. Okay, a nice straightforward disks problem. Okay, Number 6. Okay, same region, but now we're revolving about the line y equals 2. So let's see what that would look like. So 1 pi over 2. We know we look something like this. And let's see, now the line y equals 2. Well, this was 1. So now we're revolving about this line here. So since my line that I'm revolving about is parallel to the x-axis, I know I'm going to integrate with respect to x. So I'm talking about this region here. The other thing I'm noticing right away is that there's negative space between that line and my region. So this is going to be washers. I have to identify my 2 radii. So again, top minus bottom. Here is my big R. My little r just accounts for that negative space. So for big R, top minus bottom, my top is 2. My bottom is just 0. So my big R is 2. My little r is going to be my top, which is 2, minus my bottom, which is cosine of x. So now to find the volume, we're going to do pi times the integral from 0 to pi over 2 of 2 squared minus 2 minus cosine of x, quantity squared, dx. And again, this 2 is just our big R squared. And then 2 minus cosine x is our little r squared. Back to the calculator we go. And I'm integrating from 0 to pi over 2. 4 minus 2 minus cosine of x, quantity squared, dx. And I get 3.215 times pi for my answer. All right, let's see what else we've got here. Let's see. Let's go ahead and maybe we'll just do one more here. Let's do number 9. And I think that gives you a good range, different types of problems. And like I said, if we need some more practice, we can always fill in those other examples in class. All right, so using discs or washers, so we'll decide which one that is. To find the volume of the solid created by rotating the region bounded by y equals x squared plus 3. So that's going to be our parabola shifted up one. And the line y equals 7. So 1, 2, 3, 4, 5, 6, 7. So here's our line y equals 7. And we're going to take and revolve that about the line x equals 4. So let's see, if this is 7, this means this is 2 here. And so we're going 3, 4. So we're going to revolve that region about this line. X equals 4. Okay. So now, a couple things we have to figure out. So our region, let's see, created by rotating the region bounded by x squared plus 3 and y equals 7. There is obviously between this region and this line some negative space. So we know this is going to be washers. Also, since this line is parallel to the y-axis, we're going to be integrating with respect to y. All right, so we know we're going to have a big R and then a little r. Okay, and our radii are going to be right minus left. So now what I'm going to do right now is I'm going to get my function solved for x squared plus 3. So x squared is going to be y minus 3. So x equals positive or negative square root of y minus 3. So let's take a look at our radii. For my big R, well, my right boundary is 4, and I'm going to subtract. Now, my left boundary is this piece of the curve here, where I know my x values are negative. So what I'm doing is I'm subtracting the opposite of the square root of y minus 3. So that's really 4 plus the square root of y minus 3. Now, for my little r, my right boundary is still 4. And I'm subtracting, well, here my x's are positive. So I'm subtracting 4 minus root y minus 3. Oops, I don't know why I went back to purple. Sorry about that. Okay, so I've got both of my radii. Now we're going to find the volume. So it's going to be pi times the integral. Now I know my limits of integration have to be y values. So my lower limit is 3. My upper limit is going to be 7. Then I'm going to have my big R. I'm going to square that, and I'm going to subtract my little r. And I'm integrating with respect to y. So we'll go ahead and put this in our calculator. This time I'm just going to put the whole thing in. So pi math 9, I'm going from 3 to 7. Now I'm going to have to be careful here with parentheses. So 4 plus the square root of x minus 3. I'm going to take that whole thing and square it. And then I'm going to subtract 4 minus square root of x minus 3. And I'm going to square that, and that hit x. Okay, and then I get a volume of 268.083. Okay, so, I'm sorry. So hopefully that gives us a good understanding of how to differentiate between when we use discs and when we use washers. Again, all that washers means is that we have to identify 2 radii because we're subtracting out that inside volume. And the other thing we want to be really clear on is how to revolve around lines that are not the x or y axis. So we'll have another day of practice just on this material before we review and then wrap up this chapter.